All right, good morning, class.
Good morning.
Let's see here. Exam 16. Solve using the square root method. All right. So solving for x here. Let's just move this 23 over 5 to the other side. Now we can multiply both sides by 10. Let's see, we should be able to reduce this, right? Oh, it's 230 is divisible by 5. Is it 46 times 5? I think 230 divided by, yeah. This is 46 times 5. So this is just 46. So we can square root both sides. And let's see, 46 is 2 times 23. So we can't really reduce that anymore. So we have absolute value of x is positive negative square root 46. No, not yet. Yeah. So x is positive negative square root of 46. Is that what y'all got? Now for number 2, same trick. Let's subtract 1/4 from both sides. So while we're at it, let's get a common denominator here. And see if we can simplify this. 112 is 2 times 66, is that right? Yeah, 2 times 66, and 66 is 2 times 33, and 33 is 3 times 11. Meanwhile, 12 is 2 times 6, which is 2 times 3. All right, that can't be right. 112 divided by 2 is 56. This is divided by 2 is 28. So divided by 2 is 14. There, I think that's right. 2 times 2 times 2 times 2 times 7. Yeah, it's 112. So we can do this. So we are left with 7 times 2 is 14 times 2 is 28 over 3. So we have this equals this. So multiply both sides by 3. We have x squared is just 28. So the square root of x squared is the square root of 28. 28 is 2 times 14, which is 2 times 7. So you can pull those out for single 2 there. So we have this equals this. So we have absolute value of x is 2 root 7, or x is positive negative 2 times the square root of 7. So I did these long equalities, right? But in the end, I'm still looking at left-hand side equals the right-hand side. That's my major equation there. That's why we use these to put those in between our equalities. All right, any questions? Let me check and make sure I got the same answers last time we did this. Yeah. All right. So let's work on a quiz then. This would be quiz number 17. I was looking around here and I thinking we can go back to, sorry about that. Good old Scam Likely. Calls every day. Okay. On page 138, we can do this one here. Guess I need to do this one. Here's our number one. And this will be our number two. Okay. So we'll take 15 minutes. Let's see, it's 10:36, so 46, 10:51. We'll come back and work on these quiz problems here. 10:51. Get your breakout rooms going. Well, 10:52 now. Okay, class, we are back. Let's see what we can do with this thing. Let's see, A here is 4, which is positive. So it opens upward. Our axis of symmetry is at negative b over 2a. See, b here is 0. So this is at 0. So, all right. I can just look at this and I could tell you this is going to look like x squared, but it's going to be stretched vertically by a factor of 4 and then moved down by 5. So it's going to look something like that, just by eyeballing it. But if we go through the process here, all right, our axis of symmetry is at 0. So our vertex, we plug a 0 in, we get a negative 5. Our vertex is at 0, negative 5. All right, our y-intercepts is at negative 5. We just, it's the same as our vertex here. Our x-intercepts, we set this equal to 0 and solve. So we got a 4x squared equals 5. 4x squared equals 4/5. Or x equals positive negative square root of 2. Square root of 4 is 2. 2 over root 5. So let's plug that into our calculator here. I can rewrite this 2 over root 5. Usually they want you to rationalize these things. So you multiply it by root 5 over root 5. So we're looking at 2 root 5 over 5. Let's see, 5 square root times 2 divided by 5. So this is positive negative 0.89. So right about there and there is where our x-intercepts are. The domain, all real numbers, because this thing does go infinitely right and left. Our range, the lowest we go is negative 5, and we go all the way up to positive infinity. So there you have your graph. Like I said, the 4 stretches it vertically, that's why it's skinny, and the -5 moved it down 5 notches. So now number 2, create a quadratic equation with solutions plus or minus square root of 5. This one's easy. X minus the square root of 5 times x plus the square root of 5 equals 0. Right? Remember when you solve equations, you usually factor it first. If this is 0, it doesn't matter what this is. And if this is 0, it doesn't matter what this is. So when you solve, you factor and then set each one equal to 0. Right? So the solution here would be square root of 5. Over here it would be a negative square root of 5. Right? If you want, you can multiply it out, make it look like a quadratic. If we multiply that out, we got an x times an x is an x squared. We got plus the square root of 5x, then minus the square root of 5x, and then a negative times a positive is a negative. Square root of 5 times the square root of 5 is 5. Or x squared minus 5 equals 0. Right? This is the exact same as this. So you can write it either which way you want. This will work, or this will work. All right, if you look at this, this is a quadratic equation, right? Because there's an x squared in it. You can eyeball it and say, okay, and move the 5 to the other side. Take the square root of both sides. I get positive, negative square root of 5 for the solutions. So however you want to do it, that's fine. But we created a quadratic equation with those solutions. We could also do 2 x squared, right? Because what is this? It's the same thing. This is just 2 times x squared minus 5 equals 0. Basically, you can multiply it by any number you want, right? Because if you're solving this, you just divide both sides by 2, and you end up with the same thing. So this has the same solutions as this. So there's an infinite number of answers for this. This is just the most basic, simple quadratic equation with those solutions. All right, any questions? All right, let's move on. I think we left off here. We did these. Now we're on page 142. Okay, factor the binomials completely. If you remember the difference of 2 squares, a squared minus b squared, this is a plus b times an a minus b, right? So a times a is a squared. Then you got a minus ab, and then a plus ab, and then a minus b squared. These go away, and you're left with the difference of 2 squares. So if you have x squared minus a number, it doesn't matter what number it is. You have the difference of 2 squares. In this case, this is x squared minus 7 squared. This is an x minus 7 times an x plus 7. Right? There's no b component here. There's only an a and a c. This guy,
Professor,
yes.
I just tried turning in my quiz, but there's no like thing for it. There's just for the exam.
Oh, let me fix this real quick then.
Go to the assignments. It doesn't have a due date.
Oh, okay, sounds good.
What did I do here? Quiz, the quiz 17. Oh. All right, let me fix that. That's strange. There, now it has a due date. It's weird. Sometimes Canvas doesn't pick things up. Bizarre. Okay, this thing we can rewrite it as a difference of two squares. 4x squared is the same thing as 2x squared, and 81 is 9 squared. So we could rewrite this as 2x minus 9 times a 2x plus 9. All right, if we check this, we get 4x squared there, 18x minus 18x, and then our minus 81. So what about these? This one might be like, oh, that's not the difference of the two squares, is it? Actually, it is. If you think about imaginary numbers, this is x squared minus 3i squared. Remember, I is the square root of minus 1. So I squared is minus 1. So if we square this I here, we get a minus, which will cancel with that minus and give us a plus. Right? So this is x minus 3i times an x plus 3i. Right? You can see that if we set this equal to 0 and solve, we get x squared equals a negative 9. If we square rooted both sides, we get x equals positive negative 3i. Okay. This one's got a x cubed and an x in it. So first, let's pull out the, you can pull out a 2x here. So we got a 16x squared minus 1. Now this is the difference of two squares. This is 4x squared minus 1 squared. So we have the difference of two squares here. So this guy would be 4x minus 1 times 4x plus 1. Right? There's our 16x squared plus 4x minus 4x cancel out, and then our minus 1. Okay, these, we can pull a 25 out of here. So we got an x squared plus 4. And this can be written as a difference of two squares. This is x squared minus 2i squared, right? That I squared gives us a minus, and another minus turns it into a plus. So this is 25 difference of two squares. We got x minus 2i times an x plus 2i. This one up here, 7 squared minus x squared. This is 7 minus x times a 7 plus an x. Just simple difference of two squares here. All right, this one we can pull an x out. We get x squared minus 1. This is the difference of two squares. 1 is the same as 1 squared. Oh, sorry, should have pulled an x squared there. All I did was rewrite 1 as 1 squared. So this being the difference of two squares, it's x minus 1 times an x plus a 1. All right, 36, we can pull a 3x out. That would give us x squared minus 4. And 4 is 2 squared. So difference of two squares, x minus 2 times an x plus a 2. And I want to throw one in here. What if I have x squared minus 3? How would I rewrite this as a difference of two squares? 3 is an ugly number, right? Well, I can rewrite it as the square root of 3 squared, right? That gives us 3. So this would be x minus root 3 times an x plus root 3. So this not only works when you have a pretty number there like 4 or 16, you know, you can rewrite any number as the square root of itself squared. You can rewrite it as something squared and then use your difference of two squares. Nope. That's a trick for you. Now we are on page 143. So the whole point of factoring is to solve equations. Let's see what they have to say here. All right, the graph of f of x is shown below. Notice that the x-intercepts occur at -5, 0, and 2, 0. We can use the x-intercepts to write the factored form of this quadratic function by moving the x-intercept over to the other side. All right, so -5 and 2, x minus -5, and x minus 2. That's our factored form of the quadratic function for x plus 5 and x minus times x minus 2. Notice if I put a -5 in for x, this becomes 0. Sure, this is -7, but who cares? 0 times anything is 0. So by looking at the x-intercepts, we know what the function is. That's what it is. If we multiply this out, we get x squared plus 5x minus 2x minus 10, or x squared plus 3x minus 10, which is exactly what they wrote up here. So just by knowing these 2 points, we know what the function is, and that tells us what all the points are. All right, does that make sense? So 2 points make a parabola, apparently, if they happen to be where they cross the x-axis. You just do x minus each intercept. Another example. All right. X squared minus 4x is shown. Note that the x-intercepts occur at 0, 0, and 4, 0. So if we write the use the intercepts to write the factored form, we'd have an x minus 0 and an x minus 4. All right, x minus 0 is just x. We multiply this out, we get an x squared minus 4x. Same thing up here. All we did was do x minus each of the x-intercepts, and it tells us the whole parabola. So page 144. Sketch a possible graph for the quadratic function given in factored form. Looking at this, we can tell it's zeros, right? If you plug a 5 in, you get 0. So 1, 2, 3, 4, 5. All right, right there. That's 5, 0. That's one of the roots. The other one, if I plug a -2 in, I get 0. So at -2. All right, so it looks something like this. Maybe like this. All right, let's multiply it out. We got an x squared minus 5x plus 2x minus 10, or x squared minus 3x minus 10. All right, a here is 1, so it opens upward. All right, what's our, if we plug a 0 in, f of 0 is -10, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. So it's going to go through there. Our negative b over 2a is -3 over 2 times 1, which is 3/2. So that's like 1.5. All right. So if we do f of 3/2, we have 3/2 squared minus 3, there's 3/2 minus 10, 9/4 minus 9/2 minus 10, so 9/4 minus 18/4 minus 40/4. Let's use the calculator here. 9 minus 18 minus 40 divided by 4 is -12.25. So that's down here is our vertex. So that's what it is. All right. But if all we use is if all we use is these 2 points and the a, I mean, a possible one, we could have done that or done that. There's lots of possible ones, but we need the vertex to find out what it actually looks like. So let's look at another example here. All right, well, if I put a -6 in, this becomes 0. So 1, 2, 3, 4, 5, 6. -6, 0. Or if I plug a +6 in, this becomes 0. So at 1, 2, 3, 4, 5, 6. So a possible graph, it could be that, it could be this. It's going to look something like that. We know because it's symmetric here, this is at 6, 0, we know this thing goes right down the middle here. So our vertex is going to be at f of 0, in which case we get, put a 0 there and a 0 there, we get a -36, which is way down here. -36. Here's another example. All right, the graph of f of x is shown. The x-intercepts occur at 3/2, 0, and -4/3, 0. We can use the x-intercepts to write the factored form of this equation. We just do x minus that one, and then x minus a -4/3 is +4/3. All right, that's our function, which we could tell if we multiply this out, we get x squared plus 4/3 x minus 3/2 x. If we multiply that times that, we get a -12/6. If we simplify, so over 4/3 minus 3/2. We need a common denominator, so we'll do a 2/2 and a 3/3. So I got 8 minus 9, and they're both over 6. So that's a negative 1/6. So I got a minus 1/6 x. 12 over 6 is 2. All right. Compare that to this. It's not the same, right? But if I multiplied this thing by 6, I would get this over here. The reason is because setting this equal to 0 gives us 3/2 and minus 4/3. If I multiply this whole thing by 6, I still get the same solutions. Okay. The thing is it's the difference between this versus this versus this. All those parabolas have the same roots, right? The only thing that makes this thing independent is its vertex, right? We can, when you multiply your x squared, this just makes it twice as tall, 3 times as tall, 4 times as tall. If you're setting these equal to 0, each one says x is 0, right? They all have the same solutions, but they're all different parabolas. It's just a matter of how much it's stretched out. All right, so when they take these are their roots and turning it into this, see, I used x minus 3/2 and x minus 4/3. They turned it into things with whole numbers. Okay. So just using the intercepts doesn't tell you the whole function, right? Here, I'll show you. Our function here, 6x squared minus x minus 12. If I factor a 6 out, this is x squared minus 1/6 x minus 2. It's the same thing we have here. Okay, so just using the x-intercepts, that doesn't give us the whole parabola. We also need to use our vertex here. Okay, so let's see what they do. They take our each of our x-intercepts, right? And all they're doing is turning things into whole numbers, getting rid of the fractions. So they multiply both sides by 2, and you get this. Then subtract 3 from both sides, so you're setting it equal to 0. Okay, so start off with this and turn it into an equation that's equal to 0. So over here, we multiply by 3, we get this, add 4 to both sides, and we get this. So they're using these as the factors instead of just doing x minus each intercept here. All right, it's tricky because I could take this, and if I subtracted 3/2 from both sides, I'd have x minus 3/2 equals 0. Right, and then if I multiplied through by 2, I'd have 2x minus 3 equals 0. Right, these both have the same solutions. Okay, so they're just getting rid of the fractions is all. But again, just looking at the x-intercepts, it'll give you the parabola that goes through those 2 points. But unless we know this, we don't know what we're truly going for, because there's an infinite number of parabolas that go through those 2 points. All right, solve by factoring. So using the 0 factor property, this just means if you factor, you can set each factor equal to 0 to solve. So if we look at this, we could say this is the difference of 2 squares here. We could say that equals 0 if and only if, sorry, it's not even close though, 3x squared minus 4 squared. All right, this equation is the same as this equation. I can rewrite that as a 3x minus 2 times a 3x plus 2. So this is the same thing as this. Well, if this is equal to 0, then it's the same thing as if either one of these factors is equal to 0, right? If this is 0, it doesn't matter what that is. 0 times anything is 0. So that's the 0 factor property. You just factor it out completely and set each factor equal to 0. So this one tells us that 3x is 2, or x equals 2/3. This one tells us that 3x is negative 2, or x equals negative 2/3. So these would be our two solutions. All right, number 2, let's do it on its own page here. So we want to set this thing equal to 0, basically put it in the standard form first. So let's subtract 9 from both sides. So that would be 7. All right. Now we need to factor this guy. This is one that we can eyeball. I see an x squared. I know I need an x and an x. These are both positive, so I need a positive and a positive. Two numbers that multiply to give us 7, but add to give us 8 would be 1 and 7. So either x plus 1 is 0 or x plus 7 is 0. This one says x is minus 1. This one says x is minus 7. So those are our two solutions. And we can check our work, right? Looking at this guy right here, our left-hand side, if we plug a minus 1 in, we got plus 8 times a minus 1 plus 7. See, this would be 1 minus 8 plus 7. That's 0, which is the right-hand side. And we could check the minus 7 in the same way. Just plug it back into the original equation. So this guy, let's put all of our put our equation in standard form. If I add 7x to both sides, now let's see, subtract 2 from both sides. 2x. So in order to factor this, since we got this 2 here, it makes it kind of hard. Let's do our PQ trig. A times C here is 6. So we need two numbers that multiply to give us 6. B is 7. So those same two numbers have to add to be 7. So if we do P equals 6 and Q equals 1, that should work. So what we do is we take our 7x and rewrite it as 6x plus x, using that, like we did last time, over and over again. So out of here, we could pull a 2x out, and that gives us an x plus 3. And over here, we'll rewrite this as 1 times x plus 3. So we have a 2x and a 1, both being multiplied by an x plus 3. So now that it's factored, either 2x plus 1 is 0, or an x plus 3 is 0. So this one tells us x is a negative half. This one tells us x is negative 3. So those are our two solutions. Do y'all have any questions about these so far? It's just a lot of practice here, working lots of problems. That gets you good at it. All right, this one. I got an x squared over 9. I'm going to take this 2x over 3. So I have this. This one sucks. I don't like all these fractions. So I'm gonna multiply both sides by 9. That gives me x squared. And then 9 over 3 is 3, so this would be a 6x. It's 9. 9 times 0 is still 0. So I'd rather deal with this than deal with that. They have the exact same solutions. So if I'm going to factor this, I can eyeball this one. This would be an x minus 3 times an x minus 3. That gives us a positive 9, and minus 3x minus 3x gives us a negative 6x. So if I set either one of these equal to 0, I could see x is 3. If I put a 3 here, I get 0. If I get a 3 here, I get 0, right? Because this is just x minus 3 squared. Obviously, x is 3. Okay, let's see. First off, let's pull an x out of this guy. And let's rearrange them in order from highest to lowest. 4x cubed, I need a 4x squared here. The 20x squared, I would need a 20x and then 25. Okay, so looking at this, I can't really eyeball this one. I should be able to, but I can't. So in order to factor this, let's do our trick here. A times C. 4 times 25 is 100. So we need two numbers that multiply to be 100. B here is 20. So our two numbers need to add to be 20. So how about 10 and 10? They multiply to be 100 and they add to give us 20. So I'm going to take my 20x and rewrite it as a 10x plus 10x. I still have this x out here, so I'll factor out of here a 2x. That'll give me a 2x plus 5. Over here, I'm going to factor out a 5. That's going to give me a 2x plus 5 again. So I have this x, I have a 2x plus a 5, both being multiplied by a 2x plus 5. This is the same thing as 2x plus 5 squared. Okay. So if I set each one of my factors equal to 0, I got an x. Either x is 0 or 2x plus 5 is 0. This one says x would be a negative 5 halves. So we have 0 and negative 5 halves. This one happens twice. It has a multiplicity of 2 because it happens twice. You get the same solution twice. All right, this thing is a cubed in it. Our x squareds look like this, right? Well, an x cubed has an extra curve in it. Every time you increase the power of x, your graph gets another curly Q in it. So that right there would have a 1, 2, 3, 4, 5, 6, 7. This would be an x to the 7th. Notice it would cross the x-axis 7 times. It would have 7 roots. An x cubed would cross 3 times. Or it might have imaginary numbers. It might be up here, you know. Oops. Something like that. So it doesn't necessarily cross 3 times, but it has 3 curves in it. All right, solving for t. Let's see. We can pull a 2 out of here, make things a little more simple. T squared plus 9t plus 18 equals 0. This 2 doesn't matter. We could just divide everything by 2. All right, so this one, we should be able to eyeball it. We need a t and a t. They're both positive, so a plus and a plus. Two numbers that multiply to 18, but add to give us 9. 6 and 3. So t plus 6 times a t plus 3 equals 0 if and only if either 2t plus 6 is 0 or t plus 3 is 0. So this one tells us t is a minus 6. This one tells us t is a minus 3. So those are our two solutions. And again, we can always plug them in back up here to check our work. See, it's 11:30. Y'all want to take a 15-minute break here?
Sounds good.
All right, we'll come back at 11:45. All right, class, let's keep going here. Number 7. All right, let's move everything to one side. Now let's pull a 5 out of there. We can pull a 5x out, right? So that gives us a 2x minus 1. So either 5x is 0 or 2x minus 1 is 0. This one tells us that x is 1/2. So we got either x is 0 or x is 1/2. Number 8, oh, we got a bunch of fractions. Let's get rid of the fractions. If I multiply by 10, I can get rid of some of the fractions. So what if I multiply everything by 40? That'll get rid of all the fractions. 40 divided by 5 is 8. So I have an 8x squared. 40 divided by 4 is 10. So I got a 10x. And then 40 over 10 is 4 times 3 is 12. So let's move this 12. Oh, I'm missing an x. There's an x goes right there. Let's move this 12 over. Now I have something in standard form and I don't have a bunch of ugly fractions. So now let's use our trick here. A times c. Oh heck, what's 8 times 12? 96. Be a negative 96. Our b here is 10. So numbers that multiply to give us 96 but add to give us 10. Let's see here. Let's see, 96 is 2. Let's see, 96 divided by 2 is 40. We can do 2 times 48 or 3 times 32. 4 times 24. None of those are working out. Let's see. 6 times 16. One of these has to be positive and one has to be negative because it's a negative 96. So what if we did a negative 6 and a positive 16? Those multiply to give us negative 96 and add to give us 10. So we let P and Q be those numbers. So we're going to rewrite this guy here. We'll take this 10x and rewrite it as a minus 6x plus 16x. Base of our P and Q here. So we could take this, factor out a 2x. That gives us a 4x minus 3. Over here, we can factor out a 4. That gives us another 4x minus 3. So we got a 2x and a 4, both times a 4x minus 3. So either 2x plus 4 is 0, or 4x minus 3 is 0. This one tells us that x is -2, right? If we subtract 4, divide by 2. This one tells us that x would be 3/4, right? If we add 3 and then divide by 4. So those are two solutions for number 8 here. And at number 9. All right, this is standard quadratic. If we're gonna factor this, I don't think there's any number I can divide out of all of these. So let's just go with our A times C here. 8 times 25 is 200. And B is 45. So we need two numbers that add to give us 45, but multiply to give us 200. Let's see, 200 is what? 2 times 100, or 4 times 25. No, not 4 times 20. It'll be 4 times 50. 200 divided by 5. We could do 5 times 40. Or 8 times 25. Let's see, this one right here, 5 times 40, actually. They add to give us this and multiply to give us that. So let's let P be 5 and Q be 40. So we can rewrite this 45x as 5x plus 40x. So out of here, we'll pull out a 5x. That gives us a 5x plus 1. Over here, we can pull out an 8. It gives us a 5. Right, 8 times 5 is 40. So we have a 5x and an 8, both times a 5x plus 1. So either 5x plus 8 is 0, or 5x plus 1 is 0. This one says that x would be a -8/5. It says that x is a -1/5. So those are our two solutions. And again, we can always check them by plugging them back into the original equation. So number 10 here. Well, this one, we could pull a number out of both of these, right? We could factor a 3 out. All right, so we could just divide by 3. This is still 0. So this is the difference of two squares, x minus 2 squared. So this is x plus 2 times an x minus 2. So either x plus 2 is 0 or x minus 2 is 0. So x is minus 2 or x is plus 2. So that's using the 0 point property. Of course, we could have just taken this and gone, well, add 4 to both sides, square root, right? Using the square root method is faster. But they specifically asked us to use the 0 point property. So that's why we did it this way. All right, let's see. Let's multiply everything by 2. We get an x squared minus 64 is 0. 64 is 8 squared.
Ow.
So x minus 8, not 8. Yeah, times x plus 8. So x is either plus or minus 8. right? If we set that equal to 0 and that equal to 0, one gives us 8, the other one gives us a -8. And number 12. Okay, let's put everything in standard form. We can rewrite this as the difference of two squares. So we get a 4t minus 7 times a 4t plus 7. So either 4t minus 7 is 0 or 4t plus 7 is 0. This one says that t would be 7/4. It says that t is a -7/4. Those are our two solutions. Do a couple more here. All right, let's put everything to the left-hand side. 4x squared minus 11x plus 6 equals 0. All right, so let's factor this guy. We have an a times c. 4 times 6 is 24. And our b is -11. So two numbers that multiply to give us 24, but add to be -11. Let's see. 24, we got a 2 times 12. I don't think this one's gonna work out. We got a 8 times a 3, or 3 times 8. Got a 4 times 6. Let's see, what about 8 and 3? If I make them both negative, they multiply to give me a positive 24, but add to give me a -11. So let's let P be -8 and Q be -3. So I'll rewrite this -11x as -8x minus 3x. So out of here, I'll factor out a 4x. Out of here, I'll factor out a -3. So I have 4x and a -3, both times an x minus 2. So either 4x minus 3 is 0 or x minus 2 is 0. So this tells us x is 3/4. This tells us x is 2. And there's our two solutions. Number 14. Oh, these are some ugly numbers. 43. What can I do with that? Is that divisible by anything? It's not divisible by 3 or 4 or 5 or 6 or 7. I don't know. I don't think I can factor a number out of here. So let's just factor it as is. A times C. 30 times 15. 450. B here is 43. So we need two numbers that multiply to give us 450, but add to be 43. Let's see. 450 divided by 9. 9 times 50 would be 450. So that gives me 59. Let's see, 450. Guess we'll have to start at the beginning. I can do either 2 times 225. 450 divisible by 3. It is 3 times 150. If it's divisible by 4. 450 divided by 4. No. I divided by 5, right? 5 times 90. I already wrote that. It didn't work. No, that was 9 times 50. 5 times a 90 didn't work. Let's see, is it divisible by 6? It's 6 times 75, but those don't add to be 43. Is it divisible by 7? No. It's divisible by 8? No. Divisible by 9? Yeah. Move this one down. 9 times 50. It is divisible by 10, right? 10 times 45. That's getting closer, maybe. Is it divisible by 11? No. 12? No. 13? No. 14? Nope. 15? 15 times 30. That's pretty close. It's 45, not 43. Maybe we're getting closer here. Divisible by 16, 17, 18. 18 times 25 gives us 450. See, I'm just going through finding all the numbers that divide 450. This one here, 25, 35, and 8. Those work. We let P be 18 and Q be 25. 18 and 25 add to be 43. And they multiply to give us 450. So let's rewrite this guy. 43x, we're going to rewrite as an 18x plus 25x. So now out of here, I'll factor out a 3x. That gives me a 5x plus 6. Over here, I'll factor out a 5. That gives me a 5x plus 6 again. So I have a 3x and a 5, both times a 5x plus a 6. So either 3x plus 5 is 0, or 5x plus 6 is 0. So either x is a negative 5/3, or x is a negative 6/5. There's our two solutions. All right, let's see what's next. More of the same. Okay. They want us to get this down really well. So solving by factoring, let's put everything to the left-hand side. All right, we can't factor a number out of here. So let's solve it as is. A times C is a negative 70. B here is a negative 3. So two numbers that multiply to give us negative 70, but add to give us a negative 3. Let's see, 70 is 2 times 35. No, it's not divisible by 3. Let's see, how about 7 and 10? Right, if the 10 is negative and the 7 is positive, that gives us negative 70. And they add to give us a negative 3. So let's let P be 7 and Q be a negative 10. So we'll rewrite this minus 3x as 7x minus 10x. So out of here, we can only pull out an x. We get a 2x plus 7. And over here, we can pull out a minus 5. So that would give me a 2x plus 7 again. So we have an x and a minus 5 times a 2x plus 7. So either x minus 5 is 0 or 2x plus 7 is 0. So either x is 5 or x is negative 7/2. And there's our two solutions. Number 16. All right, we can't pull a number out of here, so we need to factor it as is. 6 times 24. It's 144, but it's negative. We need two numbers that give us that. B is 7. So you need to add to give us 7, but multiply to give us negative 144. Let's see. We do a 2 times 72, but that won't help. We get a 3 and a 48. 4 and a 36. 6 times a 24. Getting closer. Divisible by 7. We do an 8 times an 18. That would give us 10 though. About a 9 times a 16. I think that's it, because if we make the 9 negative and the 16 positive, they multiply to give us negative 144, but they add to give us positive 7. So let's let P be negative 9 and Q be 16. So we'll rewrite 7t as a negative 9t plus 16t. So we can factor a 3t out of here and here. So that gives us a 2t minus 3. Over here, we'll factor out 4. No, an 8. That'll give us a 2t minus 3 again. So we got a 3t and an 8, both times a 2t minus 3. So either 3t plus 8 is 0 or 2t minus 3 is 0. So this tells us t is a negative 8/3. It tells us t is a positive 3/2. And those are two solutions. Number 17. We can't pull any numbers out of there, so we have to solve it as is. Let's factor. This is going to be fun. 75 times 12 is 900. B is a negative 32. Okay, so we need two numbers that multiply to give us 900, but add to give us negative 32. 2 times 450 ain't gonna do it. 3 times 300 isn't gonna do it. 4 times 225, not even close. 5 and 180. Six and 150. 9 and 100, 10 and 90. We're getting closer. Let's see, because this is negative, we're going to need two negative numbers to give us this positive here. Let's see, 900 divided by 11, no, 12 and 75. Multiplying to give us a positive, no. A times C here is a negative 900. Okay, so one of these has to be negative, one has to be positive. So if we do 75 minus 12, we're getting closer to 32, but we're not there yet. So is it divisible by 13? No. 14? Nope. 15? 15 times 60. Now we got 60 minus 15 would be 45, right? If we're looking at all these where the second one is negative. we're at 40, negative 45. So we're getting closer. 900, not divisible by 16, not divisible by 17, divisible by 18. 18 times a negative 50. Does that work? I think that's it. Boom. Let P be 18 and Q be negative 50. They multiply to give us negative 900. And they add to give us a negative 32. So we'll rewrite minus 32x as 18x minus 50x. So out of here, we'll factor out what 3x. So it gives us a 4x plus 6. Over here, we'll pull out a minus 5. So this should be a 10x minus 10, 15. No, I'm doing something wrong. I need to pull a different number out. I need to get another 4x plus 6 over here. So, what times 4 gives me 50? 50 divided by 4 is, hold on, I'm doing something wrong. 50 minus 18 is 32. So I'll rewrite 32 as 18 minus 50. So out of here, I factored out a 3x. That's a 12x. That's a 18. Okay. So something's not working here. Right, I have to get the same factor, right? But I'm starting off with this. What can I factor out of here to get this? Well, 50 divided by 4 is 12.5. 12.5 times 4 would give me a 50x. But what about 12.5 times 6 gives me a 75. So yeah, I'd have to pull out a 12.5 here. So I get 3x minus 12.5 times a 4x plus 6. That's strange. I wouldn't think they'd give us a problem with a decimal in it like that. You see what I did there? I looked at this and was like, oh, I could factor a 5 out. But if I factor a 5 out, I don't get this thing. I have to get this. So I wrote that down. Said I have to get that. Well, what's this number going to be? Well, I have to get 50. So I divided 50 by 4 and found it was 12.5. And luckily 12.5 times 6 gives me a 75. So either 3x minus 12.5 is 0 or 4x plus 6 is 0. So this one tells me x is, if I take 12.5 and divide by 3, 4.16 with a bar over it. This one tells me x is negative 6/4 or negative 3/2. Unless I screwed something up. So I don't think I did. All right, let's look at 18 here. I can pull a 2 out of everything. That'll make things a little simpler. I can pull a 2x out. Let's do that, a 2x. So that would give me a 15x squared minus x minus 2. Okay. This 2 over here isn't doing anything. I can divide everything by 2. This is still 0. So looking at this, I need to factor that. Okay, I still got this x though, so I don't want to forget about it. So if I do a times c is negative 30, and b is a negative 1. All right, two numbers that multiply to give me 30 but add to be a negative 1. 6 times 5, right? What if I did a negative 6 and a positive 5? They multiply to give me a negative 30, but they add to give me a negative 1. So I'll take this and rewrite it. This minus x as negative 6x plus 5x. So these, I'll pull out a 3x. That gives me 5x minus 2. And I have a 5x minus 2 already. So this is 1 times 5x minus 2. So I got a 3x and a 1. They're both times a 5x minus 2. So with 3 factors, either x is 0, 3x plus 1 is 0, or 5x minus 2 is 0. This one says x is a negative 1/3. This one says x is 2/5. And there's my 3 solutions to my third order quadratic equation. Let's put this one in the standard form. 4x squared minus 31x plus 21 is 0. I think 31 is prime, so we can't pull any numbers out of there. 21 times 4 is 84. B is negative 31. So two numbers that multiply to give us 84, but add to give us negative 31. Thinking they both need to be negative. Those two negatives multiply to give us a positive. So 84, what if we did 2 times 44? No, 42. That doesn't work. 84 divided by 3. 3 and 28. Yeah, that would work if they're both negative. So let's let P be negative 3 and Q be a negative 28. So we will rewrite 31x here as minus 28x minus 3x. So out of here we'll pull out what, a 2x? That gives us a 2x minus, no, I can pull out a 4 here. Pull out a 4. 7 times 4 is 28. Over here, I'll pull out a minus 3. So we got 4x minus 3, both times an x minus 7. So either 4x minus 3 is 0, or x minus 7 is 0. So either x is 3/4, or x is 7. And there's our two solutions. All right, this guy, everything has an x in it. Everything's divisible by 10. Let's pull out a 10x. So that would give us an 8x squared minus 6x minus 9. We can get rid of this 10. So now we're just looking at that guy. So in order to factor this, our a times c here, 9 times 8 is 72. 9 times 8, that's 72. B is negative 6. So two numbers that multiply to give us 72, that add to give us -6. They're both going to be negative. So 2 times 36 doesn't work. 72 divided by 3. 3 times 24 doesn't work. 4 times 18. Right. This is wrong. This should be a -72. That makes sense. So one of them's positive, one's negative. We're getting closer. 72 divided by 5, 6. 6 and 12. If we make the 12 negative, the 6 positive. So let's do P equals 6, Q equals -12. They multiply to give us -72, and they add to give us -6. So let's rewrite -6x here as +6x minus 12x. We still got an x here. I'll pull a 2x out of this. And over here, I'll pull a -3 out. I still have this x. I have a 2x minus 3, both times of 4x plus 3. So either x is 0, 2x minus 3 is 0, or 4x plus 3 is 0. This tells us x is 3/2. This says x is -3/4. There's our three solutions for number 20. There's 6 more to do. Can we knock these out? Let's see how far we can get here. All right, this one, it's in standard form. Let's factor it. A times C is -30. B is a -1. Looking at this, we could do -6 and a +5. They multiply to give us -30 and add to give us -1. So let's rewrite -t as a -6t plus 5t. Out of here, we'll pull out a 3t. That gives us 5t minus 2. And this is 1 times 5t minus 2. So this gives us 3t and a +1, both times of 5t minus 2. So either 3t plus 1 is 0, or 5t minus 2 is 0. This tells us t is a -1/3. So it says t is a 2/5. There's our solutions for 21. For 22 here, we need to put it into standard form. 12x squared plus x minus 6 equals 0. We're going to factor 12 times 6 is -72. B is 1. So what if we did 9 and what? -8? 9 times 8 is 72, right? Yeah. So they multiply to give -72, but they add to give us a +1. So let's rewrite x here as 9x minus 8x. So we can factor out of here 3x. That gives us 4x plus 3. And out of here a -2. And that gives us a 4x minus 3 again. So we have a 3x minus 2 times a 4x plus 3. So either 3x minus 2 is 0 or 4x plus 3 is 0. So either x is 2/3 or x is negative 3/4. And that's it for number 22. So 4 more. I hate to end in the middle of the page here, but that's what we're gonna do. So let's do an exam. This is what, number 17? Is that right? That was 16, yeah. Exam number 17. Let's see. So from page 149, let's just do number 1 and 2. Solve using the zero factor property. Page 149. I want to do this one. Number 2. All right, there's your exam, and I will see y'all on Monday.
Thank you. Have a great weekend.
You too, folks.